So when we look at these different tests, the first test that we looked at was the potato chip test. Now, when we're looking at this potato chip test, there's a few things we need to make sure that we understand. What kind of test is it? This was an experiment. How do I know? Because we randomly assigned people to either eat Lay's or the Great Value brand. Then, once they did that, we had them rate how much they liked it. Okay, so this was an independent groups experiment. The manipulation was giving them either Lay's or Great Value. That means that they were independent groups. You either got one or the other, not both at the same time. Now, when we did that, there was two operationalized variables. The independent variable was the brand of the potato chip. The dependent variable was the liking for it. There were two levels of the manipulation of the independent variable. The two levels were Lay's or Great Value. Those are the two levels. So in this particular case, to test this hypothesis, we would run a t-test because we got two groups, two categories, and we have a continuous dependent variable. That's fine. Now, when we look at problems that might occur with this particular study, we got to know whether or not we're looking for problems because there were or there were not null effects. So let's go back to here. You need to know, is the problem because we rejected the null or failed to reject the null? Now, potentially, if I don't tell you either one, then there could be problems with either of them. Okay? But if we're looking at these problems, we also need to know whether we have independent groups or repeated measures within groups design. The reason why is because it matters. So for this case, with the potato chips, if we rejected the null, that means that Lay's tasted better than Great Value. All right? Well, could there be reasons why people would think that the Lay's tasted better than the Great Value, even though it wasn't the actual brand that was causing it? Could it be that we found those results because of something else, right? In that case, we have a poor internal validity. That would be because we rejected the null, but we didn't reject the null for the correct purpose. We would have made a type 1 error. We do not care about maturation, history, or regression to the mean. The reason why is because those are only problems when we have repeated measures in a within groups design. The only time we have that is when there's repeated measures. If we don't have the repeated measures, then there's no reason why we need to worry about these. Even if we did reject the null, we wouldn't worry about these because they couldn't be explanations for that. Attrition, testing, and instrumentation are also problems with those repeated measures within groups designs. We don't care about this because we have an independent groups design. All experiments, all of them, could have problems with observer bias, placebo effect, or demand characteristics. Now, we're going to have a lot less than this when people are blind to conditions. In this particular case, in this test, the researcher, was not blind, but all of my family members, they were blind. They didn't know whether or not they got Lay's or Great Value. So it's harder for them to have a demand characteristic because it's hard for them to change the response. And they all know that they were eating chips, so there's really not an issue about placebo because everybody had something there. But there could have been subtle ways that I treated them differently. Domain characteristics could have been a problem, though, if they guessed what the hypothesis was and they guessed, which condition they were in, then there could have been demand characteristics. But this was a single blind study. The researcher knew what was going on, so the most probable problem would have been observer bias because maybe I treated them differently when I gave them the Lay's compared to the Great Value. Now, this is a lot different than when we have null effects. If we found that there's no difference between Great Value and Lay's, then we would have null effects. And this could be because of ceiling effects or floor effects. Ceiling effects would mean that everybody rated both chips really high because, they love chips, okay? So if the ratings of those were all really high, that'd be a ceiling effect. If the ratings were all really low, that would be a floor effect. Also, there could also be other noise, other things affecting their measurement. Now, the measurement in this case was their rating from 0 to 10, okay? So it could have been a measurement error. Maybe I heard them wrong, for example. Could be individual differences. Maybe my wife just really hates chips and my kids really love them, for example. Could be situation noise. That is that maybe they're distracted by the lights and the camera and things, and so that was distracting. The situation, made them say something that really wasn't their actual measurement of liking. So it depends on if you get null effects or actual effect. So in order to look at this, let's go ahead and see what we would do to test this. So what I've done is I've put this into, you know what, let's go ahead and do this with the cloud, our Studio Cloud. So these are the data that we got from my family, all right? Each of the participants, the chips brand, how much they liked it, etc. So for now, we're just looking at the chips brand and how much they like the chips. So for this, we would run a t-test, t.test. And in that t-test, we would have the outcome, which is liking for chips. And we want to separate it by the chips brand. And this, we're going to tell it var.equal equals true. That gives us a student's t-test instead of another one. Now, so what we see here is, look, the mean for the great value chips was actually higher than the mean for the Lay's. But it was not significantly different. So we have a null effect. So this situation could have had problems with whatever, until we knew that we had null effects. At which point, the null effects might be because, just doesn't matter, right? That Lay's and great value just aren't different. That could be the reason why the null effects happen. It could be a ceiling effect or a floor effect. If it was a ceiling effect or floor effect, we would expect these means to be really high for a ceiling effect or really low for a floor effect. In this case, they're probably not high enough for us to say that that's what's going on. It could be because of other kinds of noise that's going on, measurement error or other things that are happening. Those would be potential other reasons besides just the fact that it doesn't matter whether you eat Lay's or great value. Okay, for the next test, we had each person had the A&W and the mug root beer in front of them. They tasted them at the same time and chose which one they liked. This was an experiment. Yes, it was an experiment. It was an experiment because they were given different levels. The levels were the different brands. This was a within groups experiment because each person got both kinds of root beer, right? They got all the levels of the independent variable. The independent variable was the brand, and the dependent variable was how much they liked it. And specifically in this case, the preference. They chose which one they liked better. Now, the problem with that dependent variable is that that dependent variable is not continuous. It's categorical. You chose which one you prefer. It was either this one or that one. We have not covered any statistics that allow us to do that. No statistic allows us to do that. There are statistics that allow us to do it. We just haven't talked about it in this class, right? So because the dependent variable is categorical, we cannot run this statistic with the tools that we've talked about so far. Therefore, we can't use any of those. Now, that doesn't change the fact that this was still an experiment. It was still within groups experiment. It was actually a concurrent measures because both of them were in front of them at the same time, right? So they did it concurrently. Because of that concurrent measure, we are not concerned about some of the things that would happen in a repeated measure within groups design. So let's say that we don't know whether or not we have null effects or we don't know if we're going to reject or fail to reject the null. Okay, we don't know if we've done that yet. But when we look at these things like maturation, history, and regression to the mean, these are all reasons why we might have rejected the null. In this case, we would say that A and W really is better than mug. Okay, that the null hypothesis is there's no difference. That's the null. To reject the null, we have to say A and W is better than mug, right? Well, maturation would mean that something about the participant changed in their maturation, right? Maybe they grew older, maybe their taste buds developed, maybe they went through puberty, whatever it happens to be, between the measurement of the mug root beer and the A&W root beer. And that doesn't seem to have happened because it's concurrent, right? We can't do that. History, a historical event needs to happen in between. Maybe COVID happens, and so people just aren't as interested in root beer anymore because they think about germs when they drink root beer. But that didn't happen here because it was concurrent. Regression to the mean would say that, hey, the measurement in one time was extreme and then they regressed to the mean. There was no, it was concurrent, so those happened at the same time. Conversely, when we're looking at attrition, as well as testing effects and instrumentation, attrition happens when people drop out. Testing happens when the test, they remember something about the test. The test was just choose between the two. So there's not a difference in testing. So instrumentation or testing is not a problem for those either. These could have been problems. Observer bias, right? Maybe whenever they picked up the A and W, I smiled a little bit or something. That would be an observer bias, okay? Demand characteristics, they would guess, I should like this one more than the other. Placebo effects. Now, in this case, they were still blind. The participants were blind. I was not, because I needed to know which cup had the A and W and which one did not. So I was not blind to which condition they were in. It was a single blind study. Now, for this study, because we're not using any of the statistics, then we're not gonna worry about that. There could have been ceiling and floor effects, but that's really not a big deal. Just so you know, in this particular case, it was 3 people who liked A&W and 2 who liked mugs, so it seems pretty split down the middle. For the next test, this was also an experiment. So everybody ate a piece of cookie, gave a rating. There was 4 different pieces of cookies that they ate, right? Those are our 4 levels of the independent variable, which was the cookie brand. The cookie brand was the independent variable with 4 levels. The dependent variable was how much they liked the cookie. That's one dependent variable. So one dependent variable, one independent variable. This independent variable happens to have 4 levels. And each person had to try each of the different kinds. So this is a within groups experiment. And each person tried each one, so they rated it after each one. So we measured it 4 times, but there's really only one variable that's being measured, and that is the liking for the cookie. All right? So there's only one independent variable with 4 levels and one dependent variable. It's a within groups design, and it's repeated measures because they repeated their rating of it. Now, in this particular study, what statistic would we run? The answer is we would actually run what's called a one-way analysis of variance. A one-way analysis of variance. And so let me show you the one-way analysis of variance that we would run here. Now I'm going to show you on this. This is JASP. I've shown you this before. The reason why I'm going to show you on JASP is because it's just easier to see. This is a particular kind of one-way analysis of variance. It's a repeated measures. Because it's the same person repeating the measure, we can't just run the normal analysis of variance, which would be an independent groups analysis of variance, right? So if one group had had Chips Ahoy and a separate group had had Sugar Free and a separate group had had Chippers and another group had had Chips Deluxe, that would be independent groups, right? We would run a different analysis of variance, one that would not be repeated measures. So this particular one says that there was a significant difference in the cookie brand. That's all it says. It says there was a significant difference in the liking of the cookie brand. That's it. Now, to tell which brand they liked more, we would have to run something called a post hoc test. And this post hoc test shows us level 1 is the sugar free, level 2 was Chips Deluxe, level 3 was Chips Ahoy, and level 4 was Chippers, the Great Value brand. What it's saying is when you compare each with each, we can test whether or not they're significantly different. And that's what these P's are. This is a P using a Bonferroni adjustment. This is a P using a Tukey. A Tukey HSD is a different kind of post hoc. You may have learned about it in Psych 2111. You can only do a Tukey HSD with independent groups, right? With independent groups. That's why we have not applicable here. We can't do that because we have to have independent groups. Bonferroni allows us to do this. So this is the P for a Bonferroni adjustment. And it looks like, now look, these aren't significant, by the way, because they're slightly above 0.05, which is too bad. But it looks like level 1 is different from the rest. That's why we got this significant difference up here. Now, the reason why these are not significantly different is because we only had 5 people in that study, and so we don't have a whole lot of variance to work with within the study. And so these probably would be more significant if we had more people doing this particular test. But certainly it looks like people liked level 1 differently than the rest. And when we look at the actual means, here is the means. Level 1 is the sugar-frees, and these are the differences. These are the other groups, okay? And it seems like people liked level 1, which was the sugar-free, significantly less than the others. But they doesn't look like they liked one particular brand significantly more than the others. Because of that, we would not be worried about null effects in this particular case. We would be worried about rejecting the null. So we'd be worried about internal validity. Now, in this particular case, this was a repeated measures, repeated measures design. So that means that we could theoretically have had all of these things: maturation, history, regression to the mean, attrition, testing, instrumentation, observer bias, placebo effect, demand characteristics. We could have had all of these things. We could have all of these things, which could be explanations to why we found a difference between sugar-free and the other groups. We could have had any or all of these things. Or it could just be that people dislike the sugar-free significantly. They dislike it. They like it less than all the other groups. That could be the fact too. But these are all potential other reasons why we could have gotten what we got. In the last test, we got the squash. We got frozen versus microwave squash. Now, I will tell you right now that anyway, this was an experiment. Yes, it's an independent groups experiment because you either got the frozen squash or the microwave squash. You got one or the other, okay? And when we actually run the t-test, let's go ahead and run the t-test on this one, which is the one we should run, by the way, t-test of liking for squash. And we're going to separate it by squash condition. And var dot equal true. When we do this, we see that there is a significant, there's a difference, right? So in this case, the mean for the group of the room temperature squash, right? That is by the end, the frozen squash became room temperature. So I changed the name to room temperature, right? Was 2.5, and the ones for the microwave was 1.3. Now this was not significantly different, okay? This, therefore, would be a null effect. So why did we get that null effect? Well, we got that null effect probably because of the floor effect, right? People they just really didn't like it. Look how low those ratings are. If we got more ratings, we might find more variance. Or if we found a more sensitive measurement where we could tell more of a difference at the low end, then maybe we'd be able to tell a difference. It could also be that, microwave squash and frozen squash just they're not significantly different from each other. That could be the case. That could be the case. Now, the way that this particular study is set up, we could not have history effects, maturation effects, regression to the mean. We can't have any of those because there's no repeated measures. This is a post-test only independent groups design, so we can't have those things going on. Now, theoretically, we could have observer bias and other things, but we're not really worried about those because observer bias and those are all explanations for why you would reject the null when you shouldn't have done it. They're explanations why you would have made a type 1 error. In this particular case, we're going to fail to reject the null, so we're looking at null effects instead of significant differences. Okay, I hope you enjoyed that. Let me just show you really quickly how to run a one-way analysis of variance. You would do this if you have 2 or more levels of a predictor or independent variable, okay, and a continuous dependent variable. So we got to have a categorical independent variable, and you can have 2 or more levels of that variable, and then 1 continuous dependent variable. In order to do this, what you would do is you would have to create a new model, and you can name that model whatever you want, doesn't matter, I'm going to name mine tape because there's a roll of duct tape right next to me. Okay? And tape, I'm going to tell the tape that's going to be an ANOVA, AOV. Analysis of variance is going to be, and in this particular case, I don't have anything with more than 2 levels, so normally I would run a t-test, but I could run basically the same thing just as analysis of variance. So let's go ahead and do that squash one only as analysis of variance. So let's do liking for squash as our dependent variable, and we're going to do squash condition as our independent variable. And let's push enter. Now notice how nothing happened. Well, something did happen. We created something called tape. That's what this thing is up here. It says that's what tape is. So we need a summary of tape. Okay? This gives us an analysis of variance. And it says, when we look at the difference between those levels, here's what we get. All right? Here's what we get. We can run a post hoc on this. For example, a Tukey HSD is a post hoc, and what it does is it looks at all the different levels of the independent variable. In this case, we only have 2, so we normally wouldn't do this, but if we had more than 2, this would be an easy way to do it. Tukey HSD of tape, and when I do this, here's what I get. It says room temperature compared to microwave, is there a significant difference? This is the P of the difference between those 2 groups. If there was more levels, then it would show each of the different comparisons. So let's say we had room temperature versus microwave versus liquefied, right? And it would show us room temperature compared to liquefied, room temperature compared to microwave, and then liquefied compared to microwave. And we would have a P for each of those differences. You only do a post hoc, though, when this analysis of variance is statistically significant. All right, thanks, everybody.